geometric series, which means we're going to be adding the terms of a geometric sequence. So if a geometric sequence has first term a sub 1 and a common ratio of r, then the sum of the first n terms is given by the following. And so here we have this formula. I want to add an additional formula that you will want to write down here, and that is S sub n equals a sub 1 minus a sub n times r over 1 minus r. And again, r cannot be 1 because we'd have 0 in the denominator if that were the case. But you can use either one of these formulas. This one would be if you knew the first term and the last term that you were trying to find. So this, for both of these, this is called the partial sum of a geometric sequence. And so on this first example, the first thing that you're going to need to do is rewrite this, or just put a -1. So what this should say is the summation as I goes from 1 to 8, 4 times 5 to the I minus 1. So it should have had that instead. So you can just put a -1 there or rewrite it. So we're finding the sum of the first n terms. Well, notice that we have kind of the setup for a geometric sequence because we have 4 times something being raised to a power. So this right here tells us our first term. So now we know a sub 1 is 4. This right here tells us the value of r. So we know r is 5. And this number here tells us the value of n. So we know n equals 8. So then from there we can actually use this formula here. So we have S sub 8, which is what we're trying to find, is a sub 1, which is 4, times 1 minus 5 to the nth power, all over 1 minus 5. And we could take our calculator. I'm going to evaluate 1 minus 5 raised to the 8th power. So we have 4 times negative 390,624 divide by -4. So we're going to divide this. Oh, no, we're not. We don't need to do that. So we're just going to get S sub 8 equals a positive, since we had a negative 1 down here now. So 390,624. Okay, so that would be my partial sum for the first 8 terms. Now, remember, you can use your calculator, so let me remind you of the summation notation, or if I hadn't done it yet, then I guess I'll just be telling you this now. So if you do alpha and then hit the window key, and notice the second thing on the list is the summation, I'm just going to use an x. We want to go from 1 to 8, and then we have 4 times 5 raised to the x minus 1, and I'm using x instead of the I just because it's easy to do that. And then we hit enter and we get our answer. So we can work that out. Remember what the summation means. We would be taking 4 times 5, starting by plugging in a 1, 4 times 5 to the 0, plus 4 times 5 to the first, plus 4 times 5, and we would continue to then add those up. That's what the summation means, add it all up. So this particular problem is not in your packet, so you'll need to add that. I think there might be a blank page on the back that you could add this to. So we are going to find the partial sum, but what we do know, so I always start by writing down what I know. I know that a sub 1 is 5,120, and these are terms of a geometric sequence, which means I can figure out r by taking 2,560 and dividing by 5,120. And when you do that, you get 0.5 or 1/2. So that's my value of r. So if I use the formula, I don't know, actually, in this case, we know a sub n. So let's grab that other formula and see if that can be helpful. So we have S sub n equals a sub 1 minus a sub n times r over 1 minus r. Okay, so using this, we're trying to find s sub n. I know a sub 1 is 5,120. I know a sub n is 20, and we know r, and we know 1 minus. Okay, boy, looking at my notes of the way I did this problem before, I used the other formula for S sub n, and I'm telling you, knowing the second formula that is an option makes things much easier. So we have, this is just 10, so 5,120 minus 10 gives us 5,110, and then we are dividing that by a half. Remember, when you divide by a half, it's the same as multiplying by 2. So we get 10, 2, 2, 0. So in case you're wondering, oh, well, what if I picked the wrong formula? I'm not going to write it all down here, but I'll just tell you it involved using the formula for a sub n from the sequence, and then it also involved solving a problem using logarithms. So yeah, think about it and pick the correct formula, because this was much easier. Okay, now if I were in class today, I would have someone in the class get up and go over and stand by the window and walk half the distance to the door. So I'll just tell you, I've measured the window, the distance from our classroom window to the door is about 8 meters. Okay, so it's roughly 8 meters. So I'd have somebody stand by the window and I would say, walk halfway to the door. And then I'd say, how far did he walk? And it would be 4. And then, okay, from that spot that you're in now, walk halfway to the door. So then they would walk an additional 2 meters. From that spot, walk halfway to the door. So they're going to walk 1 meter. From that spot, walk halfway to the door. And they're going to walk half a meter. From that spot, walk halfway to the door. And we would continue this. And now by this time, they're basically at the door. But then the question, theoretically, when you think about it, when do they get to the door? Well, this sum could keep going. But yet we know that there is an answer, and the answer is 8. So this is actually, because this never stops, you can always do another halfway. Physically, you'd be at the door, but theoretically, mathematically, you could continue to make smaller and smaller increments. So this is actually called an infinite series. Actually, we should say infinite geometric series, because it keeps going on and on. However, it converges to a sum of 8. So some infinite series converge. Other infinite series we say diverges, and we have used those words once before in dealing with sequences in series. So we're going to take a look at how can you tell if a geometric series will converge. So here's we have a formula to figure out the sum, so we don't have to find it. So the sum of the terms of an infinite geometric sequence with terms a sub 1 and common ratio r, where r is in between -1 and 1, is given this way. So how you can know if it converges? It will converge to this sum if the absolute value of r is less than 1. And that's what we're looking for. So if the absolute value of r is less than 1, and you want to test that, then you could use this formula to find the sum of the sequence. This would not be a partial sum. This would be the sum of that series, geometric series. Notice here, if the absolute value of r is greater than 1, then the terms of the sequence will not have a sum. So we would say that this would diverges, which means it does not converge to a sum. So for example, here we have an infinite geometric series, and it would keep going. So the first thing that I'm going to do on that one is, well, we can see that a sub 1 is 4, and then we need to find the value of r. So to find r, I'm going to take the second term of the sequence divided by the first. So remember, that becomes 4/5. Dividing by 4 over 1 is the same as multiplying by 1/4. So we get 1/5. Now, because 1/5, the absolute value of 1/5 is less than 1, so then it converges. And because it converges, we can find the formula for the infinite series would be a sub 1, which is 4, over 1 minus a fifth. So I get 4 divided by 4/5. 1 whole is 5/5. So we get 4 times the reciprocal. The 4's cancel, and my answer is 5. So make sure that you always check this first. You got to check the value of r, because if r is greater than 1, you can still use the formula. It's just your answer is going to be wrong. All right, for the next problem, we are finding the sum. So notice the setup here. This is a sub 1, and this is r, because it's written in the format a sub 1 times r to the n minus 1. We're looking for an infinite series, so we wouldn't be able to use our summation notation on our calculator because you'd be putting in, what, infinity? So we can't really use that. But I can check, and I can see that the absolute value, which is 1/3, which is less than 1, so I know it converges. Oops. Yeah. Okay. So then we have s, and you don't have to put the infinity sign. If you just put s without a number there, it's just kind of assumed to be that. So here was our formula. So we get 2/5, and then we're going to have 1 minus a negative 1/3. So we have 2/5 divided by 4/3, which is 2/5 times 3/4. So we get 3/10 for our answer. And it's all right if you have to use your calculator, but you should really be able to do those fractions. And this will help you remember. Okay, on the next problem, it's set up a little tricky because notice it's not j minus 1. So it's not really set up the right way. So I'm going to rewrite this as, I'm going to rewrite it so I have it in the right format. And I'm going to think of it as 0.9 times 0.9 to the j minus 1. Because now I have it in the right setup. It just so happens in this problem that a sub 1 is the same as r. So again, a little tricky in the setup. So then I double check my value of r, which clearly is less than 1. So that means it converges. So I'm going to take s equals a sub 1, which is 0.9, over 1 minus 0.9. So we get 0.9 over 0.1. Okay, now you should not need to grab your calculator because look, you move the decimal point over 1, which is like multiplying the top by 10 and multiplying the bottom by 10, and we get 9, and that's our answer. Okay. Okay, I believe that was the last example. So you guys have a homework assignment to work with. Remember, sometimes when you are answering questions about geometric series, sometimes you have to use the formula for geometric sequence to find a missing piece that you need for the series. So don't forget to check that if you get stuck because you're missing too many pieces. go back to the formula for the geometric sequence and see if you can apply that formula to come up with what you're missing for a formula for geometric series.